This video covers Lab 7, where we worked with the pulley system. And just to give you a general overview of the experiment, in our first trial we used a single pulley and attached mass 1, which was the bigger of the two masses, and we observed the grav it produced. Next, we increased the mass and added a second pulley, which was suspended from both sides, while keeping the first pulley hanging from just one side. This allowed us to compare how the change affected the system and the resulting graph. But before we did any of the trials, we had to first calculate the theoretical accelerations for both setups, so we can compare it to the experimental and get the. I also want to go over some real life examples of the pulley system, and I thought this graphic was really good. And I think the simplest one here is the well, where you pull down on the rope and you bring the bucket up with water. It's pretty simple. And then I think the exercise equipment is a really good example of the pulley system and how it could be used, as well as how versatile the pulley system is, because with workout machines it usually relies heavily on the system to lift and adjust the weights so the user can access different weights very easily. This is a simple image of how elevators work with the pulley system, and you can see both of the pulleys right there. And the idea is also simple, where the weight outweighs everyone in the elevator and can move up and down stably due to how well the pulley system is set up. Okay, this is the last example I'll go over, but I also really like this example of the pulley system for theater curtains, where you can see it all ends on this one side, so whether or not you pull or go down, the curtains will close or open. And you can see the two pulleys at the top that are contradicting each other to get both sides of the curtain to to open or close. For the materials, we had the pulleys, string, weights, computer and program, the hooks, the scale, and then we had the whole setup here for the pulley system. And then those are the weights that we used attached to the hooks and one of the pulley systems. And then you can see there we have like 100 pound weight, and then the other one was 135, I believe. And then this is the scale for some of the weights that didn't have the amount of weight listed on them, so we could just weigh them there. And then as for more of the setup with all the materials, we just have to make sure that the pulley was on the wheel here, along with the string. And then over here we have all the weights that we had, in which for the weights we had to make sure that it was over 50 for the second experiment, but less than 200. But then if you multiplied the second mass twice minus the first mass, it still had to be over 50. So then I believe we chose 100 and 135 for the second experiment. And this is a close-up of one of the pulleys.
I think it's gonna move like crazy. Wait, this is the heavier one. Yeah, I guess so.
Wait, is it the heavier one?
Yeah, that was heavier. Yeah, right.
Wait, actually, I think that.
Yeah. I don't know, that's weird. I think this is Ready?
I'll tell you.
Okay.
So just to summarize the video that you just saw, as for the procedure here, we had the mass, the biggest one, which is 1. We had to aim it or put it at the very top, so then the second mass would go all the way up to give us the best graph possible. You see me just hold the mass 1 at the very top and then just let it go fully without trying to intervene too much to get the graph to be as natural as possible. And then that would also give us the slope that we wanted for all the data.
For the first part of the experiment, we first calculated our theoretical acceleration with this equation by dividing the difference between our chosen masses by the sum of our masses multiplied by gravity. This gave us our theoretical acceleration of 3.68 meters a second squared. We then tested our masses on the pulley system and recorded the speed versus time on a graph. Then we chose 2 points on a straight and continuous portion of the graph. We know that acceleration equals the change of velocity over the change of time, so we took the change of velocity and time of our 2 points and calculated our experimental acceleration to be 3.77 meters a second squared. The percent error between our theoretical and experimental is about 2.4%. For the next part of the lab, we used 2 pulleys and again calculated the theoretical acceleration, but with a different equation. The second equation is 2 times the difference between our masses divided by the sum times 1/2 times gravity. This equation gave us a theoretical acceleration of 2.65 meters a second squared. We then tested our masses on the pulley system and recorded the speed and time on a graph and chose 2 points on a straight line again. The change in velocity over the change in time between our 2 points gave us an experimental acceleration of 2.27 meters a second squared, which gave us a percent error of about 14%. Since we have the mass and acceleration of our one pulley system, we can calculate the tension of the string. We multiplied gravity times 2 times mass 1 and 2 divided by the sum of the masses to get a tension force of 0.337 newtons. For the 2 pulley system, we had to calculate the tension of the fixed pulley string and the independent movable string. The independent string attached to the movable pulley had a greater tension than the fixed string. This may be because the force was evenly distributed and there was less work done. By comparing the acceleration of our 1 pulley system to our 2 pulley system, we can see that the acceleration of the 1 pulley system is larger. The 2 pulley system has a slower acceleration because there's less work done to move the mass.
For the conclusion, I would say we learned the most from the last experiment where the pulley was being held up by 2 ends instead of by 1 end. The distribution of force or the weight was very apparent when testing because we had to put a lot more mass on the side that was being held up by 2 edges than the side that was being held up by 1 edge. It makes the real world examples I went into earlier make a lot of sense. And for the percent error, for the first experiment it was about 2% and the second one was about 14%. I think it is harder to get a good percent error on the second half of the experiment because of all the variables that are added. And while the first experiment was a lot simpler as well, and I think a possible cause for the difference in percent error is my hand moving the pulley system a little, which would make a difference when compared to our theoretical expectation, which only includes math and not any possible defects or mistakes. I think the percent errors could have also occurred because of how, fragile the little setup was because, I ended up kind of breaking the system a lot of the time versus when we calculated theoretically, that's not something that we ever take account of. I also think that the difference in percent error in comparison with the first and second experiment we did is because the second one has a lot more variables on there and it was attached to different things, so it was a lot harder to get it stable and steady for the experiment, whereas the first one was a lot simpler where it was just one thing attached to it. And then in the background here it explains the pulley system and how the weight is distributed, especially when there's multiple of these pulleys at play because it affects the tension and the gravity. And you can see the different force and the direction it takes when it's just 2 versus when it's 1, where you could just see it just go up there. And then when it's 2, you can see that it just gets distributed a lot easier. And then you could definitely see this. You could see this earlier from our real world example of the elevator, where the 2 pulley system just distributes the weight a lot better than if it was just 1. And then for credits, it's the same as the last couple of weeks where I edited and then we both did the experiments and then Casey did the calculations and then I believe we were both in the video earlier for the procedure.